Welcome to Section 8, Lesson 8. We have learned 6 factoring techniques in this section, pulling out a GCF, factoring by grouping, the leading coefficient 1 trinomial method, the AC method for bigger leading coefficients, the difference of squares, and the perfect square trinomial pattern. Today, we wire all of them together with a single decision tree. The decision tree has 2 questions. First, is there a GCF? If yes, pull it out before doing anything else. Second, count the number of terms in what remains. The count tells you which family of techniques to try next, and the choice within that family is usually obvious. 2-term polynomials are difference of squares or sum and difference of cubes. 3-term polynomials are perfect square trinomials, leading coefficient 1 trinomials, or AC method trinomials. 4-term polynomials are factoring by grouping. The count narrows your toolbox to 1 or 2 candidates instantly. Today's 2 examples chain GCF with another technique. The first chains GCF with difference of squares. The second chains GCF with the AC method. The principle is the same in every problem: GCF first, then read the leftover, then apply the matching technique. The decision tree has 2 layers. The outer layer is one rule. The inner layer is a small lookup based on the number of terms. Step 1 is always the same. Pull out the greatest common factor. Look at every term, find the largest factor they all share, and write it out front. Whatever remains in parentheses is the smaller polynomial we will keep working on. Step 2 is to count the terms in the remaining polynomial. The count is the lookup key for which technique to apply next. 2 terms mean we are looking at a difference of squares or a sum or difference of cubes. 3 terms mean a trinomial pattern: perfect square first, then leading coefficient 1, then AC method. 4 terms always means factoring by grouping. Apply the matching technique, then repeat the whole process on each new factor. Each round can either reduce the term count or expose a hidden factor. Stop when every factor is irreducible, when no GCF remains and no other pattern fits. The chain ends and the polynomial is fully factored. Example 1. Factor 50x squared minus 8 completely. The standard rule says GCF first, so look at 50 and 8. Their greatest common divisor is 2. Pull out a factor of 2 and the polynomial becomes 2 times the quantity 20, 5x squared minus 4. Count the terms in what remains. 25x squared minus 4 has 2 terms, both perfect squares connected by a minus sign. That is exactly the difference of squares pattern, and a is 5x and b is 2. Apply the difference of squares formula. The factor 25x squared minus 4 becomes 5x plus 2 times 5x minus 2. Pair that with the GCF we pulled out at the start. The complete factored form is 2 times 5x plus 2 times 5x minus 2. The GCF stays at the front of the answer, and the 2 binomials sit beside it. Pulling out the 2 before applying the difference of squares made the recognition obvious instead of buried in the larger numbers. Factor 4x cubed plus 14x squared plus 6x, 3 terms, but every term has an x and the coefficients all share a factor of 2. Pull out the GCF first. The GCF is 2x, 2 divides 4, 14 and 6. X divides every term. 2x is the largest factor that divides them all. Pulling out 2x leaves the trinomial 2x squared plus 7x plus 3. Now apply the AC method on the trinomial. A times c equals 2 times 3 equals 6, b equals 7. 2 numbers whose product is 6 and sum is 7 are 6 and 1. Split the middle term and group. The trinomial becomes 2x squared plus 6x plus x plus 3, which factors by grouping into 2x times the quantity x plus 3 plus 1 times the quantity x plus 3. Pulling out the shared binomial gives x plus 3 times 2x plus 1. Reattach the GCF. The complete factored form is 2x times x plus 3 times plus 1. 3 factors in the answer: a monomial GCF and 2 linear binomials. The chain GCF to AC method to grouping completes in 3 lines. 3 takeaways for combining factoring techniques. They are the structure of every multi-step factoring problem in the rest of the course. Step 1 is always the GCF. Pulling it out at the start can simplify the inner polynomial dramatically and sometimes turns an unrecognizable expression into a textbook pattern. Skipping the GCF is the most common mistake students make on factoring problems. Step 2 reads the term count. 2 terms means a difference of squares or a cube pattern. 3 terms means a perfect square or one of the trinomial methods. 4 terms means grouping. The count tells you what to try next without guessing. Step 3 is to repeat. Each factor in the result can itself contain more factoring opportunities. Apply the procedure again on every factor with more than one term, and stop only when each factor is irreducible, when no GCF and no pattern applies.